Okay, right as I was getting to the end of this, it decided to cut off my clip. So here we go. We have gotten to the point where we're claiming that the average value of a function is equal to this limit down here. And hopefully we're recognizing that when we take the limit of these infinite sums, we get the integral. So really what we're looking at is the integral from a to b of f of x dx divided by b minus a. And I often write it like that when I have the b minus a, but when I actually know how long b minus a is, I'll also switch it up sometimes and rewrite it like this. Okay, so this is the formula for the average value of a function. Memorize it. Hopefully that'll be really easy because it'll make sense to you. We're adding up every single y value on the interval AB, and then we're dividing it by the length of the interval AB. And that should give you the average value. So, some examples. Let's say we're looking at the function f of x equals 2 over x squared on the interval x equals 1 to x equals 3, and we want the average value. So the formula tells us that the average is equal to 1 over b minus a multiplied by the integral from a to b, 1 to 3, of our function 2 over x squared dx. So we're getting 1/2, and we need a reverse power rule here. This is a 2x to the negative 2, so we're going to bump that up, and we're going to get an x to the negative 1, which means we need to divide by negative 1. So we're going to get negative 2 times x to the negative 1. And then that needs to be, where are we at? Evaluated from x equals 1 to x equals 3. So let me just rewrite a little because it's kind of a mess. The 2's actually cancel, so I have a negative 1 over x evaluated from 1 to 3, which means I have a negative 1/3 minus a negative 1, otherwise known as 1 minus 1/3 or 2/3. Okay, so thinking about what this means in terms of my graph, I'm talking about 2 over x squared. So this has a vertical asymptote at x equals 0, a horizontal asymptote at y equals 0, and it goes through, let's see, 1, 2, and then it goes through 2, what do we get when we plug in 2? 2, 1/2, and then it goes through 3, 2/9. So it's flattening out fairly quickly with that square in the bottom. Okay, so there's a picture of my function. And what I am now claiming is that if I average out every single one of those y values, the average value that I'm going to get is 2/3. Okay, so we can think about that certainly in the sense of average y value. What is the, if we average out all the y values, what is it that we get? You don't want to confuse that with just averaging the first and the last y value. That's not how it works. Unless you have some really nice symmetry, that's not going to give you the right answer. But you can think about it this way. If we look back at our formula that says the average value is 1 over b minus a times the integral from a to b f of x. You can rearrange a little. You could multiply both sides by b minus a and say b minus a times the average value of f is equal to the integral from a to b f of x dx. And looking at my picture, f average is a y value. b minus a, in this case 1 minus 3, is the length of the base of your region. If you multiply those two, what you're getting is the area of a rectangle. So we multiply this length by this height, we get the area of this rectangle. The statement I just wrote down is claiming that the area of that rectangle is exactly equal to the area under the curve. So you can just think about average in the way you normally think about average, but it can be a little tricky to grasp in terms of continuous functions. So you can also think about this whole business where you could say that the average y value of a function is the same thing as the height of a rectangle that will give you the exact same area on your interval as is trapped under your curve. Or, so this is what I'm really thinking about. I say that and it sounds all fancy. If you imagine you take all this blue area that's underneath the curve and you put these barriers at x equals a and x equals b, and imagine you can just melt that area so that instead of standing up in the shape it's in, it's all going to level out and fill in uniformly above the x-axis. F average is the height of that melted rectangular area that you get. So if you smush all of the area under the curve down until it's nice and flat, F average will be the height of the rectangle that you've got. Okay, and then there's one more part to this question. If f is a continuous function, this is, oh, I'm being really silly right now. I'm not thinking of what this is called. I'll think of it in just a second. Intermediate value theorem? I think so. Okay, so if you have a continuous function, it's definitely going to have to hit its average y value at some point. There's no way, unless you have a discontinuity, that your average value won't actually touch the curve, because we can see here we should definitely have some areas where the curve is above the average value and some areas where the curve is below the average value. And unless the function can just jump right over that average value, that means it has to cross that y value. So we could be curious potentially about what x value causes the function to hit that. So we're looking for this x value right here. You should absolutely not assume that it's right in between. So if we were looking at the interval 1, 3, which we are, we would not assume that the x value is 2. What we would do is we would say, well, we know the equation for a curve, and we know our average value, so let's just make them equal. And that actually works out really nicely. You could probably just by inspection say, well, then x squared has to equal 3. But if not, you could cross multiply, and then you could divide by 2, and that would get you the same thing. And then we can say that, oops, I don't want the square anymore. X is equal to plus or minus the square root of 3. So if x is equal to plus or minus the square root of 3, looking at my picture, I definitely want the plus and not the minus. So we're going to use that one. X equals the square root of 3 is the x value at which our function hits its average value of 2/3. We are specifically looking for the x value that's in the interval, and again with what I was explaining before where it has to hit it within the interval that you're looking at. Alright, so that is average value of a continuous function. So bottom line, memorize the formula. Hopefully it's easy because it makes sense. Thanks for watching.